Section 7.1 in our book introduces us to some important vocabulary and the idea of a sampling distribution, which is foundational to everything we do from now on in statistics during second semester. So really important to get this concept. We're going to hit this hard. First of all, let's recall that a distribution shows the possible values of a variable and how often those values occur. It could be a graph, it could be a table, but often we're looking at a graph. The distribution of a sample shows the values of every individual data value that we've randomly collected in that sample. Now we're going to contrast that with what's called a sampling distribution. The sampling distribution shows the parameter of a particular sample statistic from all possible samples of the same size from a given population. This is what we did in the German tank problem. We took lots and lots of samples of size 10. We calculated the same statistic over and over for every sample that we did, and we put them on a graph, and we saw what was the distribution of those sample statistics. That is called a sampling distribution. Now, what's the purpose of taking statistics and making sampling distributions? Well, we're trying to find out something called a population parameter. We're trying to estimate a population parameter. A parameter is a number that describes a characteristic of a population. This number is unknown. If it wasn't unknown, we wouldn't be trying to estimate it. Most of the time, populations are large enough and complicated enough that we can't possibly get every data value from the population. So we have to use a sample to estimate it. So this is an unknown thing that we want to know about. Okay, so we are trying to estimate this. So it's some kind of value we're trying to estimate. It might be a mean, it might be a maximum, whatever it is we're trying to estimate. Some of the symbols that we might use: the mean is mu, the standard deviation is called sigma, the proportion, a proportion for a population is called p. So those are some examples that we are trying to estimate. Now, a statistic is a number that describes a characteristic of a sample, and you will notice population and parameter both start with P, and sample and statistic both start with S, so that helps you to remember which one goes with which. Now, a sample statistic is known because it can be calculated. We get a sample of data and we actually calculate the statistic. Then we can use it to estimate a population parameter. Some examples of sample statistics that are used to estimate population parameters is we might use x bar, the sample mean, to estimate mu, the population mean. We might use S, the sample standard deviation, to estimate sigma, the population standard deviation. We might use p hat, the sample proportion, to estimate p, the population proportion. So all of these, so this is a sample mean, this is a sample standard deviation, and this is a sample proportion. So those are some symbols I want you to be familiar with. So let's just look at a couple of examples to kind of differentiate between a population and a sample and a parameter and a statistic. A pediatrician wants to know the 75th percentile for the distribution of heights of 10-year-old boys. So she takes a sample of 50 patients and calculates Q3 equals 56 inches. What's the population? Well, the population is the heights of all 10-year-old boys. Or it's the population, I should say. Well, I guess we could say it's the heights. Yeah, the heights of all 10-year-old boys. In maybe all in the United States, for example. The sample is the 50 patients, which we assume are all 10-year-old boys, because if they're not, then we're certainly not going to, it's not going to be helpful to take a 75-year-old woman and use that to estimate the height of a 10-year-old boy. Okay, so 10-year-old boys. So 50 patients' heights. Okay, so those are what we're doing as our sample. Now, what are we trying to find out? We want to find out the 75th percentile of the heights. We don't know what it is because we couldn't possibly find out the heights of all 10-year-old boys in the country. The 75th percentile. The 75th percentile is Q3, by the way, okay, because Q3 cuts off the top 75% of the data. Or sorry, cuts off the bottom 75% of the data. The statistic here is that Q3 is equal to 56 inches. This is a very specific number. We know this number because we can calculate this from the 50 patients' heights that we used as a sample. So that's the example of a population, a parameter, a sample, and a statistic. In the next example, the Pew Research Center poll asked 1,102 12 to 17-year-olds in the United States if they have a cell phone. Of the respondents, 71% said yes. So the population is all U.S. 12 to 17-year-olds. The sample is 1,102 12 to 17-year-olds that were in the survey. The parameter we're trying to estimate is a percent, because notice we said 70% said yes, they have a cell phone. So the parameter we want to find out is the percent who have cell phones. The statistic is that p hat, or the sample proportion, is 0.71, or 71%. So those just give you a little bit of example of how we talk about the difference between a population, a parameter, a sample, and a statistic. And then we're going to talk a little bit, the next video we'll talk about what is an unbiased estimator.